In this video, we're going to look at three properties of logarithms. And those are the product property, the quotient property, and the power property of logarithms. Okay, so we'll begin by assuming that x, y, and a are positive real numbers. Okay, they can be any positive real numbers. They can be even a decimal or a fraction. Now, the one thing we don't want, though, is we don't want a to be 1. Okay, and also let r be any number. Okay, it can be positive, negative, or anything. Okay, the product property says log base a of x times y is equal to log base a of x plus log base a of y. Okay, that's the product property. Notice it relates a product, right? We have an x times a y in here, to a sum, right? An addition. Okay, so that's what the product property says. Now, why is this property true? Well, that's a whole nother story. And at some point, I'll make a video that will explain why this property is true. Okay, and we'll see some examples here in a minute as well. The quotient property says log base a of a quotient, right, x over y, or x divided by y, is equal to log base a of x minus log base a of y. Okay, so the quotient property relates a division, right, a quotient, to a difference, right, or a subtraction. Okay, the power property, the third one we'll look at, says log base a of x to the r power is equal to r times log base a of x. So in some sense, this r can get pushed out in front of the logarithm here. Okay, so again, why is that true? Well, that's a whole nother story, but we'll talk about that in another video. But these are three properties that we're going to consider. So first of all, is the product property even true? Right? Is that true, or am I just making this up? Well, let's look at an example. Okay, this says find log base 2 of 4 times 8 in two different ways. Okay, so one way that we could find it is to write log base, let me pause this, is to write it like this. We could write log base 2 of 4 times 8. Of course, that's the same thing as just log base 2 of 32. Right? Because 4 times 8, of course, is just 32. Now, what's log base 2 of 32? Of course, it's 5, because 2 to the 5th power is equal to 32. Right? 2 times 2 times 2 times 2 times 2 is 32. Okay, now what's another way of doing the same problem? Well, we could do log base 2 of 4 times 8. According to the product property, we could rewrite this as log base 2 of 4, then plus log base 2 of 8. Okay, so if you look at the product property, the 2 would be like your a, the 4 would be your x, and the 8 would be your y. Okay, log base 2 of 4 times 8 is equal to log base 2 of 4 plus log base 2 of 8. Now, what is log base 2 of 4? Of course, we know it's 2. Okay, and what's log base 2 of 8? Of course, we know that's 3, right? 2 to the 3rd power equals 8. And 2 plus 3, it turns out, of course, is 5. Now, notice we got the same answer, 5, two different ways. Here, we use the product property, right? The product property. So the point is that the product property gave us the same answer that we would have gotten if we had just multiplied the 4 times the 8. Okay, now let's do another example. Let's do several examples, in fact. But this will be one more where we use the product property. How do we do log base 2 or log base 3 of 40 times 12? Okay, well, one way to do it, again, would be to rewrite 40 times 12 in terms of what it is. And 40 times 12 is 480. Okay, now how do we figure out log base 3 of 480? In fact, I don't think 3 to any nice power is going to give you 480. And we don't just do 480 divided by 3, right? That won't give us the correct answer. Right? So how do we figure out log base 3 of 480? Well, one way to do it is to use the change of base formula, right? Change of base formula. And that says this is natural log of 480 over natural log of 3. Okay, so 3 to what power gives you 480? I don't know off the top of my head, but we could plug this into a calculator. In fact, let's type this in. Natural log of 480 divided by natural log of 3. Okay, I don't know if you can see that very well, but we'll hit enter. And notice we get 6.0797. Okay, 6.0797. 0.0797, and there were some decimals after that. Okay, so that was one way to do it, was just to multiply the 40 times the 12. Well, another way to do it would be log base 3 of 40 times 12 is the same thing as log base 3 of 40 plus log base 3 of 12, right? That's the product property of logarithms. Now, how do you figure out log base 3 of 40? Well, do ln of 40 divided by natural log of 3. And then same thing over here, do natural log of 12 divided by natural log of 3 to figure out what log base 3 of 12 is. Now, notice log base 3 of 12 would be a little bit bigger than 2, right? Because 3 to the second power is 9, but 3 to the third power would be too big. And this would be 3 point something. But it turns out when you add them up, and you can try this on a calculator, plug these in, you're going to get the same answer, 6.0797. Okay, so the point is, you could rewrite log base 3 of 40 times 12 as log base 3 of 40 plus log base 3 of 12. Okay, well, you can do a similar thing with the quotient property. In fact, this one we are not even going to need a calculator for this. Log of 1,000,000 over 100. Now, what's the base here? Well, notice the base is assumed to be 10, right? We don't see any base down there, so it's assumed to be 10. Okay, one way to do this would be to rewrite 1,000,000 over 100. Now, 1,000,000 over 100 turns out that it's 10,000. Okay, and what is log of 10,000? Well, 10 to the what power give you 10,000? It's going to be 4. Okay, you could type that in your calculator. 10 to the fourth power gives you 10,000. Okay, another way to do this, though, would be to do log of 1,000,000 over over 100 is the same thing as log of 1,000,000. Then what? Minus log of 100. Now, why minus? Oops, that's supposed to be 100. Why minus? Because we are doing a division here. We're using the quotient property. Okay, so one way to do it would be we could simplify this ahead of time. We get 4 as our answer. Another way is to use the quotient property. Now, what's log of 1,000,000? Turns out it's 6. Okay, 10 to the 6th power is 1,000,000. Okay, what's log of 100? That's 2. Because 10 squared is 100, and 6 minus 2 is 4. Okay, notice you get the same answer, right? So we use the quotient property right here, and that gave us the correct answer. Okay, now finally, log base 5 of 7 squared. One way to do that, of course, would just be to do log base 5 of 49. Okay, log base 5 of 49, we can figure that out using a calculator. But we need to use the change of base formula, right? Our calculator does not have a log base 5 button, but it does have a natural log button. And it turns out, according to the change of base formula, this is equal to this. Okay, and I type this into a calculator right here, ln of 49 over ln of 5. And it turns out I get 2.418. Okay, 2.418. And there's some more decimals, but let's just round it off to the nearest thousandth. Okay, that's one way to do that. That's kind of doing it directly. But another way to do this, according to the power property, now this is not the product property, but the power property, is that we could take this 2, this exponent, and bring it out front. Right? Isn't that what the power property says way up here? Right? So notice here, the A was the, or the R was the 2, and we can bring that 2 out front. Okay, because the r comes out here. Log base a of x to the r is equal to r times log base a of x. Okay, the point is, for this problem, this would be saying that it's equal to 2 times log base 5 of 7. Okay, now how do you figure out log base 5 of 7? Well, again, you can use the a calculator and the change of base formula. And you'll see I've typed it into a calculator right here, and let's hit enter. And notice we get the same answer, right? 2.418. Okay, so it's about 2.418. So the point is that the power property worked. Okay, and I didn't just rig up this problem to make it work. It's always going to work. Okay, we can always take this exponent and bring it out front here.